In 2.5, we're going to be talking about absolute value functions. And what we're going to be doing is I want to first look at what the graph looks like, how it could be created. I want to shift it around, and then I'm going to end with solving. So the first thing I want to consider is you'll remember back in previous sections, we talked about all the different parent functions, and we talked about an absolute value function. And we said that it was this V shape that we have here. So this is our f of x equal to the absolute value of x. Now in terms of the details and how this could be graphed, this is actually even a piecewise function. We could take our f of x equals to absolute value of x and break it into two pieces, because you can see that when we are greater than 0, we have this line y equals x. Then when we are less than 0, we have the line equal to negative x, which is just a reflection of this piece upward. And then we create that V shape. So at times, in the needed given situation, we can consider the absolute value function to be these two pieces creating a piecewise function. Now it's also important to note that this is commonly used to find distance, because with the absolute value, this cannot be negative. And if we're talking about evaluating an absolute value function, we know that whatever's inside the absolute value bars, or their straight up and down bars, that it makes it positive. And so a little bit of working with our transformations. Let's go ahead and do our transformations of this absolute value function. It says write an equation for the function that has been graphed. So you can see that the original function, like you see in the previous example, is a V shape that looks something like this. And so we want to think about, how has this thing been moved around? Well, I always like to kind of start with that vertex, or that point there at 0, 0, because we can see some information from it. You can see that it has been moved 1, 2, 3 units to the right, and then it was moved 1, 2 units down. And so if you take y equal to absolute value of x and you do those transformations, that would be y equal to absolute value of x, and we would have to move it 3 to the right, so that would be minus 3, the opposite of what you think, down 2, so minus 2 outside of those function values. And then let's kind of notice what's going on from here. When we were looking at our previous one, we would have to go up 1 and over 1, up 1 and over 1, doing that y equal to x. But if you'll notice on this blue graph, let's remove this, you'll notice on the blue graph that if we went up 1 and then over 1, we would be here. So you can see the graph has been stretched. And so let's see how we can do it. Let's find another good point. You can see it would go up 1, 2 and over 1. So that would be a slope of 2 over 1. So this would be the A value that would be in front. And so we can see that this has been stretched out vertically to create this new function. So you're still going to have to apply your transformations even on the absolute value of a function graph. Now let's kind of get into the grid of it, and let's look at the solving of it that we're going to have to reproduce, especially on the homework and as we move forward into the exam. So it says solving absolute value equations. It says if the absolute value of x is equal to c, then x is equal to c, or x is equal to negative c. Because remember, whatever is inside that absolute value, we're going to take the negative away from it, and it's just going to be a positive answer. So we don't know if that x inside of there was negative or if that x inside of there was positive, because the absolute value bars would remove that sign change. And so here's what you're going to do. It says find the horizontal intercepts of the graph. When it says find horizontal intercepts, that means set your y equal to 0. So essentially, we're just solving for x. And so our steps are going to be this. Let's just kind of make some notes here. Your steps. 1, you want to isolate the absolute value. After you isolate the absolute value, step 2, you want to set up two equations and solve. So let's look at this example and apply those steps. So we're going to set this equal to 0. So this is the absolute value of 4x plus 1 minus 7. First thing we're going to do is isolate that absolute value, meaning get only the absolute value on one side. And so I'm going to add the 7 to move it over. This gives me 7 equal to the absolute value of 4x plus 1. After you isolate the absolute value, you want to set up two equations to solve this. So I'm going to split this up. I'm going to say, well, this absolute value of 4x plus 1 could have been equal to positive 7, or 4x plus 1 could have been equal to negative 7, because applying those absolute value bars would have taken away that negative. And then I'm going to solve those two simple equations. So minus 1 on both sides, I get 4x equal to 6 and divide. So x would be equal to 3/2. And then I'm going to solve the other one. So I'm going to say minus 1, 4x is equal to negative 8. So x is equal to negative 2. And so pretty two quick steps, but the most important thing that you can remember is make sure that you set up two equations. That's where you're going to get those yellow markings on your online homework or half credit on the exam. So let's work some more examples and apply this and see what we can do with it. And we'll work one that doesn't always have that absolute value, just kind of by itself, and see what happens from there. And so this one says solve. Okay, so here's my equation. I'm just going to pull it out to the side here. So I'm going to follow my same two steps from previously. First, I'm going to isolate the absolute value. Again, similar to the previous example. So I'm going to say minus 2. So it gives me negative 1 equal to 4 absolute value of x minus 2. Divide by 4. So this gives me negative 1/4 equal to the absolute value of x minus 2. But you'll notice, let's look at this. The absolute value of x minus 2 is equal to a negative. Again, absolute value, we're dealing with distance. You'll notice that this is impossible to get a negative solution. So actually for this one, once we got this absolute value by itself and we got that negative, we would say that it does not exist, or that there are no solutions to this problem. So solving these absolute value problems, make sure that you just go slow. Don't think you're crazy when you get a negative over there. It could just be no solutions. Now, the other step that we're going to approach with these absolute values is with inequalities. Now, it wasn't too bad solving with absolute values with the equal sign, because you can solve linear functions at this point, but it's just that little step of setting up your two equations. So when you're solving your absolute value inequalities, remember, this is going to be similar to the previous method. We will have to set up two equations, but make sure here that we set up test solutions. So let's write this out. Similar to above steps, and we need to remember this, we will set up intervals to test for solutions. So let's kind of look at that and see what we're doing here. So we can see it says solve, and it has this absolute value. So part 1, we're going to go ahead and treat this like we did in the previous example. We're going to isolate the absolute value bar. We're just going to treat it like an equal sign for now. So change to equality, your equal signs, to set up intervals and make two equations. So we already have that absolute value isolated, so I'm going to say x minus 5 could be equal to 4. X minus 5 could be equal to negative 4. I'm going to quickly solve those. That gives me 9 by adding that 5, and that gives me 1 by adding the 5. Okay, so nothing new on that part of the example. Next, we need to set test intervals to find where is that thing going to be less than 4, etc. So number 2, you want to set up intervals around those 2 points. And test a point in each interval in the original, keyword there, equation. Original equation. You want to go back all the way up to the beginning of your problem. So I'm going to draw a number line here, and I want to mark my 1 and 9 that I found in the previous part. Then I'm going to find numbers. These are my boundaries. I want to find numbers in each of those boundaries to help me with this. So I'm going to pick some test values to kind of help me out here. I'm going to pick some easy numbers here. I'm going to first test, let's pick x to be 0. 0 is a fun number to work with. So I'm going to go back up to my original absolute value of 0 minus 5 less than or equal to 4. So it gives me the absolute value of negative 5 less than or equal to 4, which is 5 is less than or equal to 4. And that is not true. So that means that my solutions are not going to be in this area. Then I'm going to test in the next section between 1 and 9. And so let's pick x to be 5. So 5 minus 5 is less than or equal to 4. 5 minus 5 is 0. Absolute value of 0 is 0. Is 0 less than or equal to 4? Yes. That works. So we want this interval. I'm going to test the next one. Let's pick a number bigger than 9. Let's pick 10. That sounds fun. 10 minus 5 is less than or equal to 4. So it gives me absolute value of 5 is less than or equal to 4. So 5 is less than or equal to 4. And again, this does not work. So this area does not work. So we want to find or solve this problem. So what would our answer be? Our answer would be that is in this region between 1 and 9. It's equal to, so we want to include 1 and 9. So I would say all the solutions for that absolute value inequality would be in the interval from 1 to 9. As an inequality, that would be 1 is less than or equal to x is less than or equal to 9. And so when you're working with these absolute value inequalities, you really need to go slow. The hard part is not in getting that 1 and 9, is remembering that you need to set up an interval of solutions of which ones would work. Going back to just kind of working with inequalities as well. So I hope this helps on this section. If you have any questions, feel free to contact me.